C.4 More examples on multi-level caches. In this part, I will give you two more examples. All right, so the first one, example number 18. In a multi-level cache system, if L1 miss, we know the meaning, the miss rate of L1 cache is decreased by 5%. And L2 miss rate is increased by 5%. And the hit time for L1, L2 keep the same. Then, how does the average memory access change? Increased, decreased, or sometimes increasing, sometimes decreasing. We cannot decide which one. Always true. Yeah. So that C. It depends. Yeah. All right. So to solve this one, we need to use the formula. Average memory access time formula for two-level caches. Yeah. So let's write that formula first. So T average equals hit time for L1 cache plus R1. So let me just write R1. Okay. So we can write simpler. Yeah. R1 times hit time L2 plus R2 times penalty 2. Okay, yeah. All right. Now, suppose this is the original one. So then the new one, after the change, the average new hit time L1, no change, but R1 decreased by 5%. R1. T2 hit time, no change, but R2 increased by 5%. All right. Next, we need to compare these two numbers, which one greater, which one smaller. That's simple. Okay? All right. In order to do the comparison, I like to, expand these two expressions term by term. Then we can do comparison, easier. Yeah. All right. The first one, average, the first term, hit time 1, all right, yeah, plus R1 T2 hit time plus R1 R2 P2. Yeah, that's simple. Yeah. The second one, average, new, first term the same. The second one, 1 minus 5%. R1 T2 hit. Third term, multiplication 1 minus 5% times 1 plus 5%. Then R1, R2, P2. Now we can do comparison, term by term. The first term, the same, okay? Yeah. If we do subtraction, cancel out. The second term, we can see the R1, T2 hit this part the same. The coefficient is different. The upper one is greater than the lower one. right? The upper one greater than the lower one. The third term, now we look at the coefficient. 1 minus 5%, 1 plus 5%. This one equals 1 minus 5% squared. Because we use the formula here, 1 minus a, 1 plus a equals 1 minus a squared. Yeah. Or in general, a squared minus b squared, right? Equals a minus b, a plus b, the general difference of squares formula. Yeah. This one we know less than 1, right? So then the upper term greater than the lower term. Then we can say the old t average is greater than the new t average. Okay? So the average memory access time, the change way decrease. So that's the answer. Okay? Yeah. So you can see, you know the formula. Yeah. When you start with a formula, but the second step also important. You need to know how to manipulate the formula. That's also very important. All right, so that's the first example. Second one, example 19. It is a long question, but not very difficult. Okay? In 1,000 memory references, there are 60 misses in L1 cache, 20 misses in L2 cache. Hit time L1, 1 clock cycle. Hit time L2, 5 clock cycle. Okay. Yeah, if we only use L1 cache, the average memory access time is twice as much if we use both L1, L2. So this sentence is the key condition we need to use to set up the equation. Yeah, so that is the key sentence. Yeah. Assume that the miss penalty when we use only L1 cache is X clock cycle, but when we use both L1, L2 also X clock cycle. Okay, so how much is X? Yeah. Although the question description a little long, but because we're familiar with the situation, describe it here. You know, a typical multi-level cache situation. Yeah. So we can understand easily. Yeah. Now, here we just use the average memory access time. That formula, we can set up an equation. Then find a solution. That's simple. All right, so let's start. Yeah. Only use L1 cache, the left-hand side, T1 hit time, so that's 1 plus R1. Number of R1 misses, that's 60. 1,000 memory references. So that's the right one in the denominator, so 1,000. Miss rate, all right. L2 hit time, 5. Oh, sorry. Yeah, because look at this. Left-hand side, we only use L1. Yeah, only L1, okay? Yeah, so we do not include L2 part. So we multiply miss penalty directly. Right. Then the right-hand side, we know twice as much, still 1 plus 60 over 1,000. Now L2. So this one, both L1 and L2. So both, so L2 hit time 5 plus number of L2 misses 20. Number of L1 misses 60, then X. So this is the equation. Okay, this is the equation. Yeah, based on our formula. Yeah. Then we can solve this linear equation for x. Answer 80. Yeah. That's the example number 19. Yeah. So you can see, for a question like this, typically, this is the main formula we use. Yeah. L1, both. Yeah. So that's the average memory access time formula we use. Yeah. Then you need to know, so which number known, which one is unknown, but important part. Yeah, for a question like this, important part is write the miss rate correctly. Miss rate for L1, L2, local miss rates correctly. If you can do that part correctly, then the whole question is not very hard. Yeah. All right, so let me stop here and we complete C.4.